Namaste friends, welcome back to TechZone. In this video, we are going to see different layouts in Android Studio like linear layout, relative layout, frame layout, constraint layout, table layout, absolute layout, grid layout and coordinator layout. So let's get started. Did you know that the way you arrange elements on your app screen can make or break its usability? What's the difference between a linear layout and a constraint layout? When should we use a frame layout instead of linear layout? And did you know there is a layout that allows you to stack elements on top of each other effortlessly? Today we are diving deep into the world of Android layouts. By the end of this video, you will not only understand the difference between the various layouts like linear, relative, frame, constraint and others, but you will also know when to use these each one to create seamless and responsive user experience. Today, there are various types of mobile phones in different dimensions. Some have smaller screen and some have larger and wider screens. It becomes challenging for application developer to design a screen or view which will have same looks on all screens. Android Studio solved this problem by providing different layout managers. So let's look them one by one. First, we have linear layout. The linear layout, as the name suggests, a linear layout arranges its child elements in a single direction, either vertically or horizontally. This linear layout is straightforward and easy to understand, making it perfect for simple UI where elements need to be stacked in a straight line. So a linear layout comes with an attribute called orientation where you can set it to vertical or horizontal according to your design. Imagine you are creating a sign up form. A linear layout would be ideal for stack of the fields like name, email and password vertically. You can also nest linear layouts to achieve more complex arrangements. Next, we have relative layout, which allows you to position its child elements relative to each other or the parent container. This layout offers more flexibility than a linear layout because you can align elements based on their relative positions, like placing a button below a text view or aligning it to the right of an image. Relative layout is particularly useful when you need to create more complex UI that require elements to be positioned dynamically. Moving on, we have the frame layout, a layout that stacks its child elements on top of each other. The most common use case for frame layout is when you want to display one view at a time, like in a fragment container or a loading spinner overlay. Frame layouts are simple and efficient but can become tricky when you have multiple overlapping elements. Since all children are positioned in the top left corner by default, you will need to use margin or padding to adjust their positions manually. Next, we have constraint layout, the modern and more powerful alternative to relative layout. Constraint layout allow you to create complex layouts with flat view hierarchies, meaning fewer nested elements, which leads to better performance. In constraint layout, you can position elements relative to each other or the parent container, similar to relative layout, but with more options. You can create chains, define aspect ratios, and even animate constraint all within the same layout. For example, if you want a button to always be centered on the screen regardless of screen size, constraint layout makes this easy by setting constraint to the parent's edge. It is highly recommended for most new projects because it combines flexibility with performance. For example, if you want a button to always be centered on the screen regardless of screen size, constraint layout makes this easy by setting constraint to the parent's edge. It's highly recommended for most new projects because it combines flexibility and performance. Next, table layout. Table layout organizes its child elements into rows and columns, much like an HTML table. Each row can contain multiple cells which can span across multiple columns. This layout is particularly useful for displaying data in a grid-like format such as product list or setting menu. However, Table layout can be bit rigid compared to the other layouts, and managing cell alignment can sometimes be challenging. It's best used when you have a fixed set of items that naturally fit into a grid structure. Next, we have absolute layout. It is an older layout that allows you to position elements based on exact x or y coordinates. While it offers precise control over placement, it's not recommended for most projects due to its lack of flexibility. If the screen size or resolution changes, your layout could break, resulting in a poor user experience. With the introduction for more flexible layouts like constraint layout, absolute layout has become largely useful and is generally avoided in modern Android development. Moving on to grid layout is the another layout that arranges its children in a grid structure, similar to the table layout but with more flexibility. You can define the number of rows and columns, and each cell can contain one or more elements. Grid layout is particularly useful for creating responsive designs where elements need to be adapted to different screen sizes. For instance, you might use grid layout to create a photo gallery or a calculator interface where buttons need to be evenly spaced in a grid. Grid layout is more efficient than table layout and provides better control over cell alignment and distribution. Next, we have coordinator layout. Coordinator layout, which is a super-powered frame layout designed to coordinate interactions between child views. It's commonly used for implementing material design components like app bar layout, collapsing toolbar layout, or floating actions buttons. Coordinator layout allows you to create complex behaviors such as toolbar that collapse you to scroll or floating action buttons that hides when a list is scrolled. It's a versatile layout that's ideal for creating immersive or interactive UIs. Which layout should we use? Choosing the right layout is crucial for building a well-structured and responsive Android app. Whether it's the simplicity of linear layout, the flexibility of the constraint layout, or the power of coordinator layout, each has the strength and ideal use cases. So we must choose the layout according to our project configurations. So now you just understand the difference between the layouts. In the future, you will be using all these layouts. If you found this video helpful, make sure that you hit the like button and subscribe my channel for more in-depth Android development tutorials. Also, don't forget to drop a comment below if you have any questions or topics you would like us to cover next. Thank you.